with you. I'm a little embarrassed because I'm not sure I knew that it was you, not Brianna. Last time I worked with you. But okay, so if you can, here, let me record this session. It's recording, and go ahead and verbalize the problem, and let's look at it.
All right, so this one says that given that the limit of f of x equals 4 as x approaches 2, and the limit of g of x equals infinity as x approaches 2, and the limit of h of x equals 0 as x approaches 2, and then it just gives find the limits of multiple problems below. And so the first one is the limit of the root of f of x as x approaches 2. And I just put plus or minus 2, but he counted it wrong. So do you think that that would just make it regular 2?
Like that?
Yeah. So the answer that I did was
Well, let me just look at this for a moment. So the limit of f of x equals 4 as x approaches 2. So
yes.
that could be a couple of things. That could be that, right?
Mm-hmm.
Or it could be this. So, wow, these are weird limit problems. I'm not sure I've seen limit problems quite like this.
Yeah, he kind of weird ones.
Yeah, they are. For one thing, that does not narrow down f of x. In other words, f of x could still be that, or f of x could be that, correct?
Mm-hmm.
Hold on
Yeah.
for a moment. Let me think about that for a second. No, it couldn't. In other words, if this was f of x, as x approaches 2 from the left, the limit would be minus 4. As x approaches 2 from the right, no, the limit would still be 4 either way. So that could certainly be f of x. And that could be f of x.
Okay.
So, how do we know which f of x it is? If we take the square root of it, well, the square root of that is the square root of 2x. Now, what does that do? As x approaches 2, that goes to 2. And if we use this one, x squared, and what does that do? If we take the square root of that, it's actually plus or minus x. And as x goes to 2, it goes to plus or minus 2. So I would be inclined to say the answer is plus or minus 2. Do you have answers on these?
I only have the answers that I put down and the ones that he marked wrong. I put plus or minus 2 and he marked it as incorrect.
Really?
Yeah. But I also remember him saying a little something about how if we saw that something was like in the symbol for square root and it didn't have like a negative symbol in front of it or something like that, we should just assume it's positive. But is that the case?
Here's the rule. Let's talk about that because this is a little confusing to a lot of people. If I tell you that, sorry. if I say this, then I have to take the square root of both sides to solve it. That is definitely that.
Okay.
If I say this, that is definitely that. If I say this, that is that. So when you say radical 4 without a sign, it's assumed to be positive. If you want the negative, then you have to put the negative in front of the radical. That's different than solving an equation by taking the square root of both sides. Whenever you solve an equation by taking the square root of both sides, your answer has to begin with the words plus or minus.
Mm-hmm.
Okay? So now let's go back up and figure out where I went wrong here.
So then since you are just taking the root, would it be 4?
The fact that that upper left is true means that f of x could be that, or f of x could be x squared.
Mm-hmm.
I don't think it's clear. If f of x were x squared, then the limit as x went to 2 would still be 4, correct?
Yep.
So the fact that we know that the limit is 4 doesn't help us. Either one of these could be correct, and in fact, I might be able to find a lot of other answers. Like, well, I can't think of any right off the get-go, but the fact that I can think of 2 is meaningful.
Okay.
Now we want to take the square root of f of x. Well, if this is f of x, then our answer is the square root of 2x, which is not 2. It's square root of 2 times square root of x. So that would be the answer. But if f of x is x squared, which it could also be, now if you take the square root of x squared, you actually get plus or minus x. Notice that minus x works just fine. If you square minus x, you get x squared.
Mm-hmm.
So if the square root of x squared is really plus or minus x, then as x goes to 2, the answer should be plus or minus 2. So it seems to me we have 2 possible answers. Plus or minus 2 if the original function is x squared, or plus square root of 2 square root of x, or square root of 2x. Plus only.
Okay.
And I don't know how you're supposed to tell the difference. He didn't.
Yeah, I'll have to ask him what he wanted to see on that.
In other words, this is not enough information. I can think of 2 functions where that's the case.
All right. Then I'll for sure ask him what he wanted to see off of that one because I'm really not sure either.
Yeah. All right. So let's look at the second one. The limit of g of x as x goes to 2 is infinity.
Yeah, and it wants us to find, for the next problem, it wants us to find the limit as x approaches 2 of f of x over g of x when g of x goes, or g of x equals infinity and f of x equals 4.
So they want the limit of f of x over g of x
Mm-hmm.
as what? X goes to what?
To 2.
Okay.
And f of x still, or the limit of f of x still equals 4, and the limit of g of x is infinity.
Okay, what's this go to?
So then would it be 0 because the denominator is getting bigger?
Yep. If the denominator outpaces the numerator, it goes to 0. If the numerator outpaces the denominator, it goes to infinity.
All right. That makes sense then. Yeah.
So we really didn't have to figure out a function for g of x here. As long as the denominator is going to go to infinity and the numerator is going to go to a number, then the whole thing's going to 0.
Okay.
Okay. And tell me the third one again.
The third problem is the limit as x approaches 2 of f of x over h of x when f of x equals 4, or the limit of f of
That's
x
what
is
we just
4.
did. What was the third function limit that you gave me originally?
The limit of h of x equals 0.
Okay. As x goes to 2.
Mm-hmm.
And what question did they have that goes with this? What do they want to know?
The limit as x approaches 2 of f of x over h of x.
Well, what's f of x go to?
4,
What's h of x go to?
0. So then,
What's that go to?
wouldn't that make it undefined?
Infinity.
Because the denominator is 0?
Yeah. Actually, yes, you're right. Undefined. I like to think that that goes to infinity, but it really doesn't because in one case it can go to negative infinity and the other goes to positive infinity, which means it's undefined. So undefined is the proper answer. In other words, if I say to you, what is the limit of 4 over x as x goes to 0? Well, that doesn't go to infinity. It's undefined. Because as x approaches 0 from the left, it goes to negative infinity. As x approaches 0 from the right, it goes to positive infinity. Since they are not the same, it is undefined.
Okay.
So, that leads us back to that first problem. Why did they give you that first problem when you cannot figure out what f of x is?
I don't know.
So they told you that the limit of f of x was 4 as x goes to 2. And the only thing they wanted to know was what's the limit of the square root of f of x.
Yep.
And you said plus or minus 2, and it was wrong.
Right. Correct. I don't know. I'll ask him and get back to you on that one because he might have been looking for something particular.
I don't know what he was kind of thinking here. I'm assuming that he expected the answer to be plus 2 only, but the fact is that f of x can be 2 different functions. And depending on which function it is, it matters what the limit of square root of f of x is.
Mm-hmm.
So I'm not sure how to answer that one. All right. So what else do you have?
This next one is looking for all the vertical asymptotes of the function 2x minus 2, well, f of x equals 2x minus 2 over x minus 1 in parentheses times x squared plus x minus 1 in parentheses.
Like that?
Yep.
Exactly like that?
Yes. 2x minus 2 over 1x squared plus x.
It doesn't actually seem right because that is not a quadratic that can be factored easily.
Yeah. It's looking for all the vertical asymptotes.
Right. Okay. But here's the thing. we find vertical asymptotes by finding where the denominator is equal to 0.
Okay.
And the first thing we do before we do that is see if we can cancel anything out. Well, I can write the top. If I take out a greatest common factor, I can write the top like that. Now the bottom becomes this. You sure that's the bottom?
Yep, parenthesis x minus 1, parenthesis, and then another parenthesis x squared plus x minus 1, parenthesis.
Now, notice that the x minus 1 cancels.
Yep.
In which case, that eliminates a vertical asymptote. It creates what is called a hole. You're familiar with holes?
Yep.
There's a hole at x equal 1 that does not go away. Just because I cancel that with that, I still have the hole there. And
Okay.
the only vertical asymptote that is going to happen is when this is equal to 0.
Okay.
That doesn't factor, so I got to use the quadratic formula. What is it? How do I solve that using the quadratic formula?
You would do -1 plus or minus the square root of 1 squared minus 4, 1 times -1, all over 2. So then that'd just be
That's
-1 plus or minus the root of 5.
plus or minus the square root of 5, correct?
Yep.
So there's your two vertical asymptotes.
Okay.
In other words, if I'm graphing this, let's see, that would be 1 plus, what's the square root of 5? About 2.2. So that would be 1.2 divided by 2. So one of these answers is 0.6. That's a vertical asymptote. And the other vertical asymptote is at -1 minus 2.2, which is minus 3.2 divided by 2. That's minus 1.6. I'm rounding everything off. So there's your two vertical asymptotes. And then we know that there's a hole. In other words, this function probably looks something, let's see, there's a horizontal asymptote at the y-axis, y equals 0. So the function undoubtedly looks something like this.
Okay.
And there's a hole right there at x equal 1 that does not disappear just because they canceled out. Okay? However, the fact that the x minus 1s canceled out does mean that there is no vertical asymptote at 1. And normally you would expect there to be a vertical asymptote wherever the denominator is 0. But not in this case, because those factors canceled out, it makes it a hole instead of a vertical asymptote.
All right.
Now, whether it does that in the middle or not, a lot of times it either is going to do that in the middle or it might do this, something like that. It's not really asking for what it does in the middle. Since it just asks you for the vertical asymptotes, we gave it to them. The vertical asymptotes are -1 plus or minus square root of 5 divided by 2. That's two
Right.
different vertical asymptotes.
Okay.
Okay.
Yeah, that makes sense then.
Okay.
All right.
What else?
This next one's kind of long,
Okay.
so I want to make sure that we have time to finish it. I got the first half of it right, but the second half just confused me, so I'll just read out the whole thing.
Okay.
So the function h of t equals negative 4.9 t squared plus 122.5.
T.
Nope, just 122.5.
Serious?
Yeah.
Wow.
And yep, it says it gives the height in meters of an object that has fallen from a height of 122.5 meters.
Oh, okay. That's why there's no middle term. I was going to say,
Yeah.
this is a physics problem. This is
It,
projectile motion, and
yep.
it's in meters per second squared.
Mm-hmm.
It's
Yeah.
not in feet per second squared. Otherwise, that would be minus 9.8 or minus 16.
Yep.
Okay. So the moment you told me minus 4.9 t squared, I knew we were talking about something falling based on the force of gravity. Now, normally there's a t in there, and then normally there's a constant. But the coefficient of t is the initial velocity, and the initial velocity in this case is 0. So there is no t. So this tells you the height at any point in time. Well, what's the height at t equals 0?
122.5?
And that's correct, right? That's where it's dropped from?
Yeah.
Okay, what are they asking?
All right. It says the velocity at time t equals a is given by the limit of h of a minus h of t over a of t.
Hold on. The velocity at t equals a is given by what?
The limit of h of a minus h of t over a minus t. As t approaches a.
Yeah.
And then it says, find the time it will take for the object to impact the ground and its velocity at impact.
Yeah.
And so
How much calculus
I
have you
managed
had?
the time at 5 seconds.
How much
But
calculus have you had?
yeah.
Have you had the power rule yet?
I think so.
Have you had the product rule or the quotient rule or the chain rule?
We've had the product rule. I know we've had that one.
Okay. What you're looking at here, what that is the first derivative. That's the definition of the first derivative. As t approaches a. That's the exact definition. Okay?
Okay.
So, let's take the first derivative. In other words, v of t is equal to the first derivative of h of t. The velocity is always the first derivative of function, or of position rather. And if I just use the power rule here, what do I get? I get minus 9.8 times t. So that's the velocity at any point in time. So what is the velocity as t approaches a? Minus 9.8a.
All right.
Now, what was the second question they asked?
It asks for the time it takes for the object to hit the ground and the velocity at impact.
Okay.
Those are the things it asks for.
Okay. So we know what velocity is. Let's go back to the height function. What's the height when it hits the ground?
0.
Okay, so I'm going to plug in 0 for height. I still have my height function here. and I have to solve this. And that will tell me at what time it hits the ground. Well, if I merely solve this for t, what do I get? I get t is the square root of 122.5 divided by 4.9. Do you have your calculator?
Yep.
Go ahead and do that.
So that's 25.
All right. It's actually plus or minus 25, right?
Yeah.
Because I'm solving an equation by taking the square root of both sides. But the minus 25 does not make sense in the context of the problem because time can't be negative. So we throw that out and we only use 25 plus 25.
Yeah.
So
Oh,
that's
no.
the
I
time
forgot
to
it
take
actually
the
be 5.
ground. So here's the velocity function. What's the velocity when it hits the ground?
Um, I forgot to take the square root, so it's actually 5, not 25. But
Okay.
the velocity, would that just be negative 9.8 times 5 then?
Which is what? Minus 49.0 meters per second. Now, why is it minus?
Because it's going down,
Exactly.
right?
Yes. If it was going up, it would be plus. In other words, when you're talking about velocity, velocity is a vector. There's a difference between velocity and speed. The speed as it hits the ground is 49 meters per second, but the velocity has to have direction on there also. And it's going in a downward direction, so it's negative. Okay?
Okay.
Now, we didn't do it the hard way. And it kind of looks like they wanted you to do it the hard way. By giving you the limit quotient definition for first derivative. In other words, it looks like they wanted you to recognize that velocity was the first derivative of position or height,
Mm-hmm.
and that this is the first derivative, the definition of first derivative. So velocity is this. It's just that we have an easier way to do it by using the power rule. So by using the power rule, we did this rather quickly.
Okay.
Okay.
I like rather quickly.
Well, for sure. I mean, once you, are you taking calc?
I'm in trig PreCalc, but he says that he doesn't like the PreCalc, and so he's just teaching it like Calc A.
Okay. All right. So, unfortunately, the entire country teaches calculus in a certain way. And the way they do it is by starting you off by the most difficult concept in the entire semester. Truly.
All
This,
right.
this limit quotient definition is one of the hardest things you'll do the whole semester. And once you learn the power rule, the product rule, the quotient rule, and the chain rule, you never use it again. So you don't ever go back to it. Because now you have 4 much easier ways to take the derivative of a function. You can see that it was really easy for us to take the derivative of the height function
Mm-hmm.
just by using the power rule.
Yeah.
Well, suppose I could do it by this other way. H of A, we just fill in H of A for t, and we subtract that, and then we do the math, and you'd end up with the same thing. We could do it this way. It's just it would have taken me an extra half hour to explain it, I think. Well, hold on. Maybe, yeah. Unfortunately, my eraser doesn't work on this program. So the only thing I can do is scroll down, but let's see if I can give you a little bit of how you would do it using the way they wanted us to do it.
Okay.
So they want us to take the limit of, well, what's h of a? If h of t was minus 4.9t, then h of a is minus 4.9a squared. What was the rest of it? Plus 122.5?
Yep.
So that's h of a, right?
Yep.
We were given h of t, so h of a is merely substituting a for t. Okay,
Yep.
minus, well, h of t was minus 4.9t squared plus 122.5, and it's all over a minus t.
All
And
right.
taking it as a goes to t. No, as t goes to a,
Mm-hmm.
which you'll notice the bottom, I think it's t minus a, is it not? It's not a minus t. I think it's t minus a.
It's a minus t.
It is a minus t? Okay.
Yeah.
All right. If we start there and we try to simplify that, look what happens to the numerator. The numbers cancel, right?
Yeah.
Hold on a second. So it's h of a minus h of t all over a minus t.
Yep.
Okay. And what are we supposed to find the limit as?
T approaches a.
In other words, that's the entire a part of this problem?
Yeah. That's what it gives us, and then the only things that we're looking for is the time it takes to reach the ground and the velocity when it reaches the ground.
That's the only questions?
Yep.
Okay. So if I try to solve this, I get 4.9t squared minus 4.9a squared all over a minus t. And I want the limit of that as t goes to a, correct?
Yeah.
Well, notice what the top is. That's difference of perfect squares. Ah, yeah, I believe it is. That is difference of perfect squares.
Yep. Okay.
But it's not the square root of 4.9, is it?
I think it's just
That's not an even number. So what this would be, the numerator would be the square root of 4.9t minus the square root of 4.9a times the square root of 4.9t plus the square root of 4.9a. In other words, if I treat it as difference of squares, I believe that's what it factors into. It does. Okay? And I'm dividing all of that by A minus T.
Yep. So.
Well, I can factor out a square root of 4.9. So I get what? Square root of 4.9 times T minus A times, I can factor out a square root of 4.9 there, which makes that whole thing that times T plus A all over A minus T. Well, T minus A and A minus T cancels to that.
Okay.
So it looks like I have minus 4.9 times
T plus A.
T plus A. And that's very close to our minus 5 meters per second.
Mm-hmm.
Now, why is it not the exact thing? As T goes to A, then this goes to 2T or 2A.
What goes? So as.
In other words, T plus A, as T goes to A, goes to
Oh.
T. So you really have minus 9.8 T. Well, I might have made an arithmetic error here because there was lots of opportunity to make mistakes when we're trying to use the limit definition quotient. Notice that when I used the power rule, it was really straightforward.
Yeah,
That's
for
why
sure.
you always, hold on a second. That's what I got, minus 9.8 T. That was the first derivative. That's what I got doing it the second way also. Minus 9.8 T.
Yep.
So
So.
the velocity is the same regardless of which way you do it. And that's the way
Okay.
it has to be. It's just that the limit quotient definition is a much harder way to do it. In other
For
words,
sure.
once you don't have to use that anymore, you're always going to use the power rule. The power rule got us to the answer lickety split. I mean,
For
we
sure.
got it in 10 seconds, minus 9.8 T. And then that's the velocity when it hits the ground. And of course, it's going to hit the ground when h is 0. So it's easy enough to figure out the number of seconds it takes to hit the ground. Once you figure out that number of seconds, which was 5, now you can figure out what the velocity was as it hit the ground, because that comes after 5 seconds.
Okay.
So 5 times that minus 9.8 is the velocity that it's going when it hits the ground.
All right.
Yeah, I hate the fact that they start off calculus forcing you to do this, because that's just one of the hardest things you've ever had to do in math at this point. It really is. I mean, I know the sequence of math, and there's not much harder when you first get to calculus than having to do the limit quotient definition.
Yeah.
When it's not necessary. Why do they do that? Why don't they just start off teaching you the power rule and then the product rule and then the quotient rule? And then it's relatively simple. It's relatively straightforward after that.
Mhm. I wish.
Well,
Yeah.
I just don't get it. I really don't. I don't know why they do that. It demoralizes new calculus students. It's unnecessarily starting with the hardest. If I was going to teach you to ski, I wouldn't drop you on the most difficult slope first. I'd drop you on a beginning slope. And until you
Yeah.
master that, and then I'd take you to the medium slope, and then I'd take you to the hard slope. Well, they don't do that in calculus. They drop you right on the hard slope first.
Yep.
All right.
I don't know. It's crazy, but
What else do you
it
have?
makes everything else seem like a cakewalk.
What else do you got?
This next problem says to discuss the continuity of f of x equals x minus 2 over x squared minus 4.
All right. Again, we're going to have something that cancels. In other words, always factor if you can. So when you factor the bottom, what do you get?
X minus 2 times x plus 2.
And now that goes away. So what you end up with is 1 over x plus 2. Now, let's graph that. Where's the vertical asymptote?
Negative 2.
Where's the horizontal asymptote?
Would it just be at 0?
That's y equals 0. So this thing's going to graph like this. It's going to be hyperbolic in nature. But there's one additional discontinuity. Where does it happen?
It's the whole at x equals 2.
Yeah, right there. So, in terms of discontinuities, we have an infinite discontinuity at minus 2, and we have a removable discontinuity at plus 2.
Okay.
Okay?
All right.
That's what holes are, is removable discontinuities, and whenever you're up against a vertical asymptote, that's an infinite discontinuity.
All right. So then removable discontinuity at
is a hole. A removable discontinuity means a hole.
All right, and then a non-removable.
The only other discontinuity I'm familiar with is a jump discontinuity, which would be something like that.
Okay.
Okay. Or that's also a jump discontinuity.
All right.
It's not the same as a removable because I have that there. In other words, if that wasn't there, then it would be a removable discontinuity. It's just a hole. But as long as that is defined at that point, then it's a jump discontinuity.
All right.
Okay. What else?
Let's see here. This one just says to find the limit analytically of the limit of square root of x plus 1 minus 2, and the minus 2 is outside of the root. Yep. Over x minus 3.
X goes to 3.
Yep.
How did I know that? Seriously, how did I know that?
The x minus 3 on the bottom, if the 3 from the equation was in, it would be 0.
Really, the only difficult limit problems are the ones where it's equal to 0 divided by 0.
All right.
If you plug in 3 for x, that's what you get. You get 0 in the numerator, 0 in the denominator.
Yep.
Okay? And 0 over 0, you don't know what that limit is. That's indeterminable. So you have to manipulate this thing. And when you see radical signs, the way to manipulate it is to multiply top and bottom by the conjugate.
Okay.
Okay, well, what's the conjugate of the top?
The square root of x plus 1 plus 2?
Yep. I got to multiply the bottom by that same thing because I'm only allowed to multiply this fraction by 1. That's the number 1. Now, what's going to happen when I do this is it's going to turn into something other than 0 over 0. Okay? The top
Okay.
turns into this. X plus 1 minus 4. The bottom, just go ahead and leave it as what it is. That times this. We don't need to even try to distribute that. What's going to happen is the top, notice, turns into x minus 3. Now I can cancel that with that. And now I have 1 over the square root of x plus 1 plus 2. And now evaluate it as x goes to 3. What do you get?
Let's see here. The square root, or 1 over 4?
Uh-huh. That's your answer. Now, there's basically 3 ways to do limit problem. There's 3 techniques. One is factoring. The other is where you do this, you multiply by the conjugate. And you usually use this method whenever you see a radical sign, like this. Because I'm not factoring any of that. Okay? I can't factor any of that. But what I can do is multiply by the conjugate, and that eliminates the radical sign from the numerator, still leaves it in the denominator, but now when I resubstitute, I no longer get 0 over 0. I get a number over a number. So remember this technique whenever you see a limit with a radical sign in it. It could be something like this. Square root of x minus 4 all over, let's see, as x goes to 16. So we would want 16 minus x. In other words, if I do that problem right there, I get 0 over 0, right?
Right.
So the way I'm going to solve this is by multiplying top and bottom by the square root of x plus 4. And that will solve all the problems.
Okay.
And then reevaluate it. The second time you reevaluate it, you will not get 0 over 0. You'll get a number like we did, 1/4.
Yeah, okay. That makes sense.
What else you got? You got any
Right.
limit problems? Because that's the third technique.
Any what problems?
Trig.
Not really.
Okay.
No, this one was just kind of trying to get us to understand.
They haven't gotten to the trig limit problems yet with you.
Oh wait, is that like cotangent, cosine, that sort of a thing?
I'm sorry, what?
Is that like sine, cosine? Is that what you're talking about, those?
Yeah.
And I've got one of those.
They start you off by teaching you this one because you don't have any way of figuring this one out on your own.
Yeah, and
that one. And they tell you just memorize it. In other words, there's no way for us to do the math. You haven't been taught enough calculus yet to do this. So they tell you memorize it. They also tell you to memorize this one.
Non equals 0, right?
Exactly. Memorize those two, and then you can do pretty much all the trig function limit problems they give you. But you always have to start out with that as a base and this as a base. You have to know what those two are. Be able to do any of the others.
Yeah. Okay.
Okay. What else? You got any more? We probably got time for one more.
All right. Then let's go with this one. Find the limit of, well, it's the limit of the cotangent of pi of x over 6 as x approaches 5.
I'm sorry, as x approaches 5. And that was
Yep.
the limit of cotangent of what?
Pi x over 6.
Like that?
Yep.
Exactly?
Yep.
Okay. So what happens if we just substitute? Then it's the cotangent. That's always your first step.
All right, so that's just the cotangent of 5 pi 6.
Uh-huh. What is
And that's,
the, well, let's see. What's the tangent of 5 pi over 6? And we'll just take the reciprocal of it.
all right, so then that's,
Tangent of pi over 6 is 30 degrees, which is 1 over root 3. So this would be 5 over root 3. So that's going to be 5 root 3 over 3. That's the tangent of 5 pi over 6.
okay.
So the cotangent must be 3 over, I shouldn't have rationalized it in the first place. I didn't need to rationalize that. Cotangent's the reciprocal. It's square root of 3 over 5.
All right.
That's why a lot of
Yeah.
schools, including Vista probably, when you take trig, they tell you not to worry about rationalizing stuff. Because what happens frequently is you rationalize something and then you're looking at its reciprocal function and you have to rationalize it twice. So to avoid that, they just tell you don't rationalize. If you have an irrational denominator, just leave it that way. I don't know if that's what Mountain Vista has told you or not. You took trig last semester?
Yeah.
Okay. Well, not
Last time we were
particularly
picky about it.
significant. But in this particular problem, you can kind of see why it's the case. Because we figured out what the tangent was, and it had an irrational denominator. But what we were really interested in was what the cotangent was. So we're really going to take the reciprocal of that immediately. No need to rationalize now.
Okay. Yeah. All right, that makes sense then.
And whenever it's a direct substitution problem and it does not result in 0 over 0, it is easy, always. The only problems that are hard are where you get 0 over 0. Let me just, in the last 5 minutes, let me do this. What's that equal to?
That's 0 over 2, which is 0.
Okay, so if the numerator goes to 0 and the denominator is any number whatsoever, it goes to 0. Now, what's this?
That does not exist.
Exactly, undefined. Actually, you're right. It does not exist. It doesn't exist because the limit from the left is plus infinity or negative infinity. The limit from the right is plus infinity. Since they're not the same, it does not exist. But you can see what happens. If the 0 is in the denominator, it does not exist. If it's in the numerator, it's 0. Every problem is either one of these two cases, except if it's 0 over 0. So the only difficult ones are the 0 over 0. And those are the ones that require you to either factor, multiply top and bottom by the conjugate, or use some of those trig limit identities. In other words, at some point when they're giving you limit problems, they're only going to give you 0 over 0. These aren't
Yeah.
tough anymore. You know,
Mhm.
if they say, what is it as x goes to 3, you plug it in, it goes to 3 halves. That's a piece of cake. That's not a hard limit problem. It's only difficult when it ends up being 0 over 0, and you substitute in. And then you
All
have to
right.
do additional stuff. Every other one is no harder than 6th grade arithmetic.
Yeah, for
I
sure.
mean, anything other than 0 over 0. It's either 0 or it does not exist.
All right. Who knew there were so many ways to make 0 over 0 then in that case, because they pop up all over the place.
Well, all of the ones they're going to give you on a test are going to be 0 over 0. Trust me. It's
Yeah.
because the others are too easy. They're not going to give it to you at this level of math. They're going to give you the ones that end up being 0 over 0 when you substitute in what it's going to. I might be wrong. They may give you a couple of easy ones, but in general, that's the difficulty and limit, are the zeros over zeros, nothing else.
Yeah.
Notice even the sine x over x, as x goes to 0, that's 0 over 0. That's why
Yep.
it's hard. That's why they tell you that that actually goes to 1 and memorize
Mhm.
it.
Okay.
With the cosine one, that's 0 over 0 also. But that limit actually does go to 0. So 0 over 0, you never know where it's going without further work.
All right.
Okay. Morgan, I'll let you go unless you have any last questions.
No, that should be good. I think we got through actually just about everything.
Okay, great. I will talk to you next time.
Thank you so much.
All right.
See ya.